So, how's the Wi-Fi holding up here?
Very good.
Good, awesome, because my presentation uses none of it. So, how's that for an introduction question? So anyways, it's actually a very important question because I've gone to a lot of conferences lately where the internet is suspect at best, and what you're finding is people have their Dropbox active, everything else active, and it's causes your complete system to go down. So how would you like instead to be able to create an app that shares data with everybody else without requiring all of the cell phone or Wi-Fi infrastructure? And not only that, but I just want to kind of change the way we think about the web, and especially the peer web. Who reads the user agreements when you actually install some software? Wow, one person, all right. Do you realize how much data you're giving away, personal data you're giving away? Okay, she realizes firstborn and all of that. Beautiful. And, you know, especially when it comes to topics of the peer web, you know, people think about data loss, they think about data theft, and they think about things like Edward Snowden in terms of how much data people are really collecting. So, as was stated, I am indeed a principal SDE at this aforementioned company. And I'd like to think that I'm bringing a little bit more metal to the company. So most people recognize me mostly for this particular project, and so I'm starting to kind of get more away from this and onto other things. But what's very fascinating about this project is the fact that now Google and Netflix are the biggest contributors to it. Who would have guessed that Google and Netflix and Microsoft would be working on a same project all at one time? So really, this is about starting conversations. And back in 2011, 2012 timeframe, you know, we had this great idea, Chris Williams and I, of, you know, how do we change the world? How do we, as software developers, fundamentally change how we interoperate with the world? And everyone was welcome, whether they drank alcohol or not. It was just a convenient name since we happened to meet at a bar when we started that. But that ended up turning into JSConf, which I think a lot of people, I've seen a lot of swag around, so that's really kind of cool that a lot of people who came here also supported us there. But going back to Cascadia JS 2012, Chris Williams came up with this talk to basically challenge us all and to say, what are we doing as developers? Are we creating the next Flappy Bird to, you know, create a few moments of joy, or are we fundamentally doing something for betterment of society as developers? Are we helping grow new developers? Are we helping in areas of hard science? Those kinds of questions. And so that's really kind of a mantle that I picked up and ran with. So let's talk a little bit about the Internet of Things. You know, it really is about the things and how they're connected to each other, whether it's your Nest that you have at home or a Raspberry Pi. You know, quite honestly, a lot of that's very interesting. I mean, I have literally a stack of these boards at home. I have no idea what to do with them all, but I am a collector and I'm a maker of basically just about anything. But what's really kind of interesting about this is to see a lot of people building a lot of really, really fascinating things, but yet leaving the door wide open on security, which really, really troubles me. But I think when it comes to the Internet of Things, I think the most important piece that you're missing is this: your phone. Your phone is largely who you are nowadays in terms of it's your central access point for pretty much anything. Whether it's paying for something, whether it's controlling your house, whether it's opening doors, etc. Your phone is usually where it's at. And so that's why I really wanted to focus on the phone as being that piece that really changes what IoT is. So taking that idea from Chris, and really let's take on some big challenges here. So for example, could we reinvent manufacturing as we think of it today? And the answer is absolutely. For example, these factories have millions or thousands of machines that are all interconnected and all need to transmit data. So how do you actually wire those things up and save these companies a lot of money, millions upon millions of dollars, because these companies, keep each piece of their hardware for years, 20 years or more. How do you allow them to modernize without costing them a fortune? Here's another one. How do we improve the lives of communication of everybody, regardless of economic status? Whether you are in the lower economic brackets or the upper economic brackets, you should have the same access to communication everybody else does. That's fundamentally important to me, is that everybody should have access to information. And regardless of whether a nation state decides that you should have internet access or not. So that's more of a political issue, but I think it's still fundamentally interesting, especially some of the research that's going on now around radio white space and allowing the internet to be pretty much anywhere. But I think also helping in times of crisis. IoT has a huge role to play in helping in times of crisis. Because what happens? The first thing that happens is that the cell phone infrastructure completely fails. Your communication infrastructure completely fails. How do you fix that? Here's the answer: IoT and the phone. And so not only will it help first responders be able to find who is in need of assistance, but also help people find and connect with their loved ones to make sure that they're not panicking and they know exactly what's going on. And indeed, going even further, saving lives. Because as people such as Reporters Without Borders go into hostile zones, what happens? Well, they leave behind all sorts of interesting tracing data about themselves. Why? Because your phone, of course, is emitting any number of pieces of information. But if you use it specifically only as a peer device, that doesn't happen. And that's why I think it's very important. Now, most of all, I believe when we're developing these kinds of applications, especially as we're building things, Internet of Things, we believe, especially I believe, that you as a user have a Bill of Rights, and that we as ethical developers must abide by them. So I will just coin it as the device's Bill of Rights. Now, as part of this, we're working with Bluetooth Low Energy, and Wi-Fi Direct to provide that local discovery mechanism. The ability to discover who's around you is both fascinating but yet terrifying at the same point. So I'll try to enumerate exactly those kinds of rights that you should have as we're developing these applications. And I'll refer to Kim Cameron, who is a computer scientist who works on identity issues, so that you have a basic understanding of what we're trying to go for. So Cameron's laws of identity. The first law is that the solution discloses the least amount of information and the best limits its use for its stable long-term use. So what that really means is that the user's information does not go out on the air unless they specifically say so. And then users also must be prominently notified when exactly it is going out there. Discovery is different than any type of other services because it has imminent dangers along with it. Why? Because, for example, stalking, harassment, and so forth. When you're broadcasting this information, you're opening yourself up to that. So users must be able to, of course, disable this kind of feature, and they must specify constraints on that, such as if I'm leaving work, I don't want to be notified anymore. So that's where it's really key, is to help people keep boundaries. Because if someone's being harassed, especially over these kinds of programs, what kind of recourse do they have? Well, turning it off isn't exactly the right answer, but certainly limiting access to the harasser certainly does. Now that is a total key part of limiting harassment, but it's also about limiting people's access to getting people's locations as well. So the second law is pretty pretty self-explanatory, and so you have this, and then you have the digital identity systems must be designed so disclosure is limited and only justifiable place given a relationship. Now, these two, the previous law and this law, kind of work together. That the user's data only must be exposed in the smallest amount to the smallest number of devices within the user's desire. That's it. Now, number 4 is a really huge kind of law, and I don't expect everyone to read all of this, but basically the user's ID that you're giving out must not necessarily be their true name, but just something that represents who they are for immediate purpose only, not to keep it out there in perpetuity. And then, of course, you also must keep it open that other people can use other providers for your particular application. Now, the 6th law is, once again, rather long, but what this really means is that it has to be understandable to humans. Well, I don't think that's very possible, so we'll just keep on moving. The 7th law is that we will use our technology to enable itself and the community to use the identities that will be separate from all other identities. So hopefully, basically, we'll convince others that we are providing an identity system that other people will start to buy into. So you might ask yourself, is all this privacy a bunch of nonsense? Am I full of crap up here? Possibly. But there are a lot of people that still say if you've got nothing to hide, then you've got nothing to fear. That's one of the most ridiculous statements I've ever heard, is because why don't you just give me your email password, your Slack, GitHub, and everything else, and I'll just post it to your employer, to your insurers and everyone else. You still have nothing to hide? I don't think so. But you also might say, well, our phones themselves broadcast a lot of information. What do they broadcast? Well, they broadcast not only a cell phone number, but also the equipment ID that it has and your subscriber number based upon who you're using. So how do you actually minimize a lot of that? Well, when we're talking in privacy terms, we're saying, first, do no harm. Make them no more vulnerable than they already were. So it's my belief that a lot of these addresses that we have right now are kind of permanent, but I think that they can be random in the future, and there's no reason why they shouldn't be. Now, when it comes to owning your own data, I think it's really, really key is the fact that now we have a way of talking to one another that we own our own data. We are not sending it to Facebook. We're not sending it to Twitter. We can send it back and forth and keep the ownership of the data by ourselves. What kind of implications does that have? Well, for example, if you had something like this around your house where each of your things are emitting data, well, you can start to collect it on your phone, and then you can decide whether you send that data off to somebody else. So, what we came up with was called the Thali Project, and that was to serve as the basis of what we're building here. And it's a Indian and Nepalese term, and it's basically for plate. And usually, it's a plate of various different things, such as holding 6 flavors of sweet, salty, bitter, astringent, and spicy. Now, we feel that the ideas behind all of that become very, very interesting, especially as we start to think about privacy, access control, and so forth. Each of those are little dishes in the big thing. So let's actually show you enough of my blathering on my soapbox. Yes, I will type in my password is 1234. Don't judge me. And so what we have here is we have a device here, our Nexus 6. Who would have guessed a Microsoft guy would have a Nexus, but here it is. And we have a Nexus 9 tablet, I think. All right, and so what we can do is we can start to send messages back and forth. So for example, I can type in JSConf here, and sure enough, it immediately showed up right here. And how is that possible? Because if you can see right there, there is no SIM card in here, nor am I connected to any Wi-Fi. The only thing that I have running right here is Bluetooth right now. So how it works is that it actually uses Wi-Fi direct for discovery purposes, and then it uses Bluetooth to do the data syncing. Now let's actually go through a little bit of that, of how we actually built it. So what we thought is, well, gee, this could be a bunch of Lego blocks that we can just put together. And why I'm here is because, well, you always bet on JS because, well, everybody does, right? That's what everybody builds their solutions on, so we might as well follow suit. But just as well, thinking about it, your phone here is more powerful than servers that you would buy 10 years ago. It has so much capability and so much storage that why wouldn't you use it as a server? And in fact, companies such as Uber and others are already doing just that to offload a lot of computation and a lot of storage directly off onto your phone. So we really want to be able to take full advantage of everything from down to the encryption stack to all the way communicating with the Bluetooth and Wi-Fi directly in Node. But Node itself doesn't exactly do that. So unfortunately, since Node is tied directly to V8, we want instead to run on every device. And JX Core, which is a kind of a fork from Nubisa, allows you to do just that. It has a number of additional features that regular Node doesn't have, such as shared memory concurrency, and so forth. But the biggest part is the fact that you can swap out which particular JavaScript engine that you happen to be using. And why that's important is because now if you go to iTunes or if you go to Google Play, guess what? You can start shipping these kinds of Node apps today. They have right here the Wi-Fi shopping list, and this is from the JX Core folks, on how you can just share with your friends a shopping list over Wi-Fi. So, like I said, you have all of this capability right in the palm of your hands already today. Now, how did we deploy it? Well, thanks to Brian LaRue's liver and himself. We have Apache Cordova, which allows us to basically use it as a packaging mechanism for us to deliver the data as we need to. But it's not that we're actually using any of the APIs. We're actually writing all of our stuff as Node modules. There's no real Cordova magic happening here. And when I was showing you the postcard app that we have here, which, by the way, if you go to github.com/Thali Project/postcard app, you can actually run this yourself. What's neat about this, and even though I was showing you just how instantaneously this was going between these devices, you have to think it's actually going through Node and it's going through PouchDB to synchronize with one another, but yet it's blazingly fast, and that's really cool to see. And really, it's about enabling communication. So what exactly are our phones and tablets today? Well, what are they? They're radios. There are any number of radios, whether it's Wi-Fi, whether it's Bluetooth, it all has the same capability in terms of communicating with one another. So why not be able to use those things directly instead of having to use the Wi-Fi, public Wi-Fi or something like that? Now, for security, obviously, if you're carrying the most important parts about your company, your most private details, you obviously want it secure. So for that, we're using TLS and public keys. So for each of us, when you install one of these apps, we'll get a public key, and that will be used for authentication and authorization purposes. And not only that, but we actually will deep down to the PouchDB level enforce those ACLs. Now, a good question to ask, especially when you're doing identity exchange with a particular device such as this, is how do you get exchange IDs with one another without absolutely hating yourself? And that was a really hard question for us, especially because originally we're like, oh yeah, QR codes, that's easy enough. Just walk up to another device, hold it up, and maybe they'll line up, and then we'll have a complete identity exchange. Turns out that wasn't really easy at all because it's rather terrible, actually. So what we came up with was an idea using the coin flipping algorithm. So that we could exchange public keys back and forth with one another. And yes, there are attack vectors that maybe a 1 in a million chance that you'll get a man-in-the-middle attack, but for the most part, we're using these keys in such a way that we only advertise it when we're trying to do identity exchange with someone, so that's a very, very small window. And not only that, but it's a small window, and chances are if there's a man-in-the-middle attack, it just wouldn't happen at the right time. It would have to be very, very coordinated. So really what we want is we want something that just easily says that I give this to Tracy has one, and I have one, and I said, okay, my number is 1, 2, 3, 4, 5, 6. She says, okay, yes, my number is also 1, 2, 3, 4, 5, 6. Let's go ahead and pair these devices together. So that is probably the least painful way we could think about doing security. Now, when we're talking about doing these devices, because we're talking about supporting this on both iOS and Android right now. So basically, you can go out, you can download Thali, and you can run it today. But what's really fascinating is the sheer number of Android devices and the sheer number of versions of that. We want to make sure that every time we do a delivery that we're not breaking something. So this is actually our CI environment here, which is, as you can see, a ton of phones just all hooked up to a single server. And every time we do a GitHub push, sure enough, it hits against our CI server and spits out the results as a gist. So we live and die by this. Now, where are we going in the future? Well, that's kind of a hard question because there are a lot of ideas of where we're going. Right now, we're still kind of an experimental platform for building these pure apps, but there are very concrete things that we want to do. For example, we will want to do mesh networking. So for example, if I want to start to send data to the back of the room, I might not have range to do that automatically. What instead I would do is I would send the data halfway around the room to somebody else and then send it via another couple of people until it finally reaches its destination. In the meantime, it's still encrypted at rest, so you might see a little file on your device, but you can't actually open it. And the other thing is getting around on the general internet. So if we're available on the general internet, then we can use something like Tor, for example, to completely hide your traffic using Tor hidden services, not only to hide your traffic, but to also get around the rules that most people have on their local routers, which is to not allow local traffic to go back and forth, so we can get around all of that. That, and we're also investigating, for example, radio white space Wi-Fi and allowing that to be used as well. And what that is basically it's using unused channels within Wi-Fi, and it's able to, right now, we're working with Microsoft Research to enable, for example, Indian villages to talk to one another by setting up these Wi-Fi beacons between the two, just using that white space that nobody else uses right now. So as I said, this is no more than what you saw here, than just an NPM module. So all you really have to do is type in JX using JX Core, npm install Thali, and you're ready to go. Now you can also go and visit our sites at thaliproject.org, but together I think we can make the peer web great again. So with that, thank you very much.